All right, in this problem it says we have this Pentagon NQRTW and it was dilated with the origin as a center to create a new Pentagon, which is N prime, Q prime, etc. And vertex R prime is located at 6, 2. Okay, so and the question is, which rule best describes the dilation? So as you can see here, all of the answers are telling us we're going to multiply x by something and we're going to multiply y by something. So just in case you were unsure about what dilation was, it just means we are multiplying by some factor to get our new R prime or this new pentagon. Okay? So the first thing we need to know is, well, where does R start? What's our R starting place? And if we look on the graph, let me make this a little bigger. R is 9, 3. Okay, so 9, 3. And then R prime, they tell us, is 6, 2. And let's go ahead and plot that point, 6, 2. So this is 6, 2, and that's R prime. Okay? And then once we find that number that we're going to multiply x and y by, then we could create the new drawing. It's not asking us to do that, but that's what you would do. So I need to multiply 9 by something to get 6, and I need to multiply 3 by something to get 2. It's not obvious what that's going to be. If R prime was, well, let me give you an example real quick. So if R prime was 18 and 9, I need to multiply R x by 2 to get 18, and then y 3 by 3 to get 9. Okay, so this one is easy to see, but we've got this right here. So what I would do is I would look at all my answers and start to substitute in these different answers to see which one works. Okay, let me show you what I mean by that. So when I have R, I'm going to rewrite R over here. R is 9, 3. And let's take A, for example. A says, let's multiply x by 1/3 and y by 1/3 and see what we get. See if that's going to be R prime. And again, we want to get, this is our goal right here, to get 6, 2. So if I multiply 9 times 1/3, I can convert that to a fraction. You multiply straight across when you're multiplying fractions, and you get 9 over 3. 3 goes into 9 3 times. 3. Okay, we don't want 3. We want 6, 2. Our goal, let me write the goal down, 6, 2. Okay, so this doesn't work. This one doesn't work. Let's try the next one. And they want us to multiply by 3. Okay, times 3. Well, if I multiply 9 times 3, I'm going to get 27. And again, this is my goal. So this doesn't work either. So now we're left with 2. We've got 3/2 and 2/3. Okay, so let's, let me erase this. Let's try the 3/2. So times 3 over 2. So you can tell they're testing you on multiple levels. Can you read a graph? Can you plot a point? Can you multiply fractions? Okay, and I know multiplying fractions is, a lot of my students struggle with that. And all you do is you just, multiplying is the easy one, but adding is a little more difficult. But multiplying, you just multiply straight across. So 3 times 9 is 27, and 1 times 2 is 2. 27 over 2. Well, that's not it, right? That number does not equal 6. So this can't be it. Okay. Now let's look at the very last one, 2/3. Let me erase this right here. And I'm just going to change color just because I can. 2/3, 2/3, because it's our only other option. If this doesn't work, you know, what can we do? So 9 times 2/3. So we turn that into a fraction. We multiply numerators and denominators straight across. 2 times 9 is 18, and 3 times 1 is 3. 18 divided by 3 is 6, which is what we want. And let's test the 3 as well. So that's going to be 3 over 1 times 2 over 3. Multiply straight across, and we get 6 over 3. 3 goes into 6 2 times, and that's exactly what we want. Okay? So D is our answer. I hope this helps, and I will see you in the next one.